Greetings everyone, the most powerful and most advanced open source public locally available to use video generation model Wan AI from Alibaba Group has been published. So in this tutorial you are going to learn everything about this model and how to run it on your Windows computer. If you want to run it on a cloud machine locally on Rampod on massive compute, this is the tutorial that you have been waiting for. Wan AI is so powerful that it is able to compete against the paid services such as Thinlinc, Runway ML, or the other ones that you can imagine of. You can run this model totally locally for free forever on your computer. And imagine you are getting the quality of the paid services such as Thinlinc. It is even able to compete with the OpenAI Sora model. It is so good and so high quality. And you can use this model on your computer. The model weights are totally publicly published. In today's tutorial, I will show you how to one-click install and use it in a very advanced Gradio application that I have developed. The model is just amazing. Currently supports text to video, image to video, video to video. And we have been waiting for image to video for a long time for public models with such quality and power, and it is here. Not only image to video, this model extra supports video to video as well. And they have published it open source. It is truly SOTA, state of the art, and today we are going to learn everything about this model. They have published 14 billion parameter and 1.3 billion parameter model, and the Gradio application that I have developed is able to run this model as low as 3.5 gigabytes VRAM GPU. Therefore, even if you have a low VRAM GPU, you will be able to use this amazing model really fast. The Gradio application I have developed is so easy to install and use, but it has all the features that you need. And I have generated non-cherry-picked videos for you to show you. Okay, let's look at some of the more generations I have made. There is nothing cherry-picked. They are the first trials I have made. The prompt is here, the uploaded image is here, and let's look at the fidelity. This is 14 billion parameters image to video model. You see, this is the fidelity of the image. This is just perfect. No deformation, nothing. It is perfect. And here another example I have made. This is made with the 14 billion parameters text to video model. This is the prompt. I made the Claudio AI to write prompts. It is for free. I will show in the tutorial. And you see, this is the generation. This is next level. This is at the level of the paid services that you pay a lot of money and you wait a lot of time. And here another image to video. So this is the prompt, this is the generation. As you are seeing, it is just mind-blowingly good. It is amazing, and you can see the input image is here. The fidelity of the model is just amazing. And here another image to video. You see, this is just amazingly animated. You can see the input image is here. This is a text prompt. This didn't work very well, I think, but it is how it is, as you are seeing right now. And I also generated an anime video like this from the 14 billion text video, and the quality is just mind-blowingly good. This is literally a professional level anime. You are seeing the quality, the animation, the smoothness. It is just perfect level. In one generation, I have forgotten to write prompt. I written it into negative prompt, and this is the result as you are seeing. So do not forget to write your prompt, but you can also provide negative prompt. Of course, I didn't provide in the other examples. If you don't write the prompt, it will generate something like this. So the rest of the tutorial will be like this. I will show you how to install and how to use the application on Windows in details. So watch the Windows tutorial part to learn the details of the application. I will make comparison with the RTX 5090 and RTX 3090 Ti for all the models on this computer as you are seeing. So I really recommend to watch the entire tutorial to see the speeds on the newest generation GPU and also a very decent powerful GPU RTX 3090 Ti. RTX 5090 is performing amazing. I have made it available to install for RTX 5000 series as well, whether it is RTX 5070, 5080. It will work on all of them. It is working with Python virtual environment, so it will not impact any other of your AI applications. After the Windows tutorial part, I will move to the cloud services. So if you don't have a powerful GPU, you will be able to install it on mass compute. This is my recommendation with L40 GPU or a better GPU, and you will be able to generate whatever video you want with extremely cheap prices. Then after the mass compute, I will show how to generate and use on Rampod. So I will cover everything that you need for this, and I am updating this application. Just make a reply to the post or the video, and hopefully I will try to implement the feature that you need. So as usual, I have prepared a very detailed post where you will find all of the necessary instructions to install Wan 2.1 application on your Windows or on mass compute or Rampod. I really recommend to read this post extremely carefully from top to bottom. You will find the installer zip file at the top of the post or at the bottom of the post, where you will find as an attachment like this. So let's download from the attachments. For this application to work on Windows, you need to have installed requirements. To install requirements, I already have a requirements tutorial. For RTX 5000 series, I also recommend to install CUDA 12.8. You will learn how to install it once you follow this tutorial video and its resource file. This is totally public video, so I really recommend to watch it before starting installation. Move the installed file into one of your hard drives. Do not use shared drives like OneDrive, Google Drive or anything. Extract the archive. After extracting the archive, you will see the files like this, the installer files. First of all, you need to run installer. Do not forget that. So there is Windows install.bat file. Double click it. It will ask you this, click more info, run anyway. Do not run it as administrator because it will break your installation. The installation is totally automatic. You don't need to do anything. This will install everything for you. If you have 5000 series GPUs like RTX 5090, 5080, 5070, we have RTX 5000 series installation. This installation is also working with older GPUs, so I am going to install that way because I can also use my RTX 3090 Ti with that. So double click it. What is the difference of this one? This is using the latest nightly version PyTorch and also Torque Vision and also precompiled flash attention. For this version, this is working on RTX 5000 series perfectly fine. Just wait for installation to be completed. If you encounter any errors, you can select all of the installation logs, copy, paste into a text file, and you can email me that error logs if anything happens, but it shouldn't happen if you follow the requirements tutorial. Once you see that this folder is generated, during the installation you can begin downloading the model files. So for downloading model files, we have Windows download models files.bat file. Double click it, more info run anyway. It will ask you options to download the video models. So the very fast working model is the Wan 2.1 text video 1.3 billion parameter models. This is extremely lightweight. It is working as low as 3.5 gigabytes of VRAM having GPUs. Its resolution is 640 to 640. The best working resolutions are 480 to 832 or 832 to 480. This model is also supporting video to video. This is the only model that supports video to video. Unfortunately, this model is not supporting image to video. The second model is Wan 2.1 720 pixels image to video model. This is the most VRAM, most GPU power demanding model, but it is also the most powerful image to video model available to use right now as an open source, as a model that you can use locally. There is also alternative 480 pixel image to video model. This is at least 3 times faster than the 720p model to generate because it is lower resolution. You can also use this. And the fourth option is the 720 pixel resolution text to video model. This model is the most capable model to generate videos from text prompts. This is way better than the 1.3 billion parameter model. So you can download them one by one by entering their number, or you can download all of them with option 5. So I will use option 5. The models are huge, however, I have optimized the downloader so it will download with the maximum possible speed. You can see that I am getting 50 megabytes per second. I am going to get over 100 megabytes per second on my local computer. On cloud machines, I am able to get over 1000 megabytes per second. You will see in the next chapter of the video when I install on massive compute and also on Rampod. So sometimes some people reporting that their model downloading fails. How you can fix the problem is open this Windows download models.bat file. You can open it with any text editor. I will open in Notepad. Then you need to remove this line. You see, this is for speeding up the download, but if you are getting error, you need to delete this, save and run the downloader again. I am still trying to figure out how this error occurs. I reported this issue to the developers, but meanwhile this is the solution that you can make. Then follow the installation and model downloads. The installation already have been completed, so I am going to move my already downloaded models to here to start using it, but you can see that it is downloading the necessary models extremely fast, as you can see right now. So let's just close this. Let's go back to my previous installation, which is inside here, models. So I will cut this and I will go back to my new installed folder and I will delete the models like this and I will paste the model, and yes, I am ready. So after the models have been downloaded, the installation has been completed. How I am going to start? You see there is startup.bat file, double click it, more info run anyway. Remember, do not run anything as administrator. Moreover, all of my AI applications generates a virtual environment. Therefore, they are all isolated and they will never break any of your existing applications. So this is our interface. It is extremely advanced and simple to use. We have the model selections from here. As you change them, you will see that the parameters are changing, the GPU presets are changing. What are the GPU presets are doing? It is deciding that how much of the model will be kept in the GPU memory rather than your system memory. You can see that the numbers are changing. If you get out of VRAM error, you can reduce this number and try again. It will use lesser VRAM if you do that. So let's begin generation. We also have prompt enhance option. So you can type a simple prompt like a cat walking on a grass field and you can use this prompt enhance. When you first time use it, it will download the necessary models. What it is going to do that it is going to use a local LLM and it is going to enhance your prompt. This is from the official repository implementation. And you see that it improved our prompt to a cat strolls gracefully through a sunlight grass field, its tail swaying gently behind close-up slow motion shot. However, you can further improve this prompt if you want. You can use LLMs like ChatGPT or Claude AI to improve it further. I will show the improvement for image to video and video to video in the following chapter. So let's generate a video with RTX 5090 and see the speed. It will fit into VRAM entirely. We can see how much VRAM it is being using. So nvitop, and we can see that how much VRAM it will use like this. And also I am recording a video right now, therefore I am using a lot of GPU power. I also made some slight overclocking like 300 plus megahertz for core and 1500 megahertz for memory. And we can see the speed. Yes, it is 4.25 second IT. If you want faster results, you can reduce the number of inference steps here, but 50 steps is working really best. I really don't recommend unless you have to. It's also pretty fast. You see it is already 11 steps, 12 steps, so it will take around 3 to 4 minutes on this GPU. But what about older GPUs? Let's also start another instance with the RTX 3090 Ti that I have. To start it, I will copy paste this startup.bat file, edit its content, and I am going to limit it to CUDA visible devices 1. So this application will only see my second GPU, then double click it. And now this is running on my second GPU. So let's copy this prompt and hit here and we are ready to generate. You can also change the seed. You see it is random seed by default. You can change the video saving FPS and number of frames, but 81 frames is the best. You can also reduce this or increase it, it works. And the quality of the video is 5 by default. So let's make the aspect ratio different for this one. I will make it 9:16 and generate. Now we will see the speed of the RTX 3090 Ti as well. You see the 3090 Ti we're not using any VRAM, therefore we will see the exact VRAM usage, and it is using 6 GB of VRAM memory. However, if you have lower GPU, you can select the option 4 GB and it will make the number of persistent parameters to 0. In that case, it will use only 3.5 GB of VRAM memory. I have tested all of the configurations and you see 5090 almost completed. The 3090 Ti is getting like 8.6 second IT and 5090 is like 4.18 seconds IT. However, since I am recording video, it is slower. I will show you the actual speed with stopping video and testing for you. Okay, so I have turned off recording and regenerated a video on RTX 5090 to test its real speed, and it is amazing. It took only 2 minutes 59 seconds for 50 steps for the 1.3 billion parameters 480 pixel resolution model, and RTX 3090 Ti took 7 minutes 11 seconds for 50 steps for the same. So here I am recording the durations and the tasks and you can see the difference. You will notice that the VAE decoding took a lot of time, 9 seconds, and on powerful GPUs you can disable tiled VAE decode for the 1.3 billion parameter models and it will be almost instant. Currently, FP8 version is not working. I have reported this issue to the developers of the library for speed up optimization that we use, and hopefully once it is implemented, it will start working and it will be even faster and lower VRAM. Hopefully. So what else you can make? Our application saves every prompt generated. When you open the outputs folder from here, you will see that there is outputs folder, and inside outputs folder, you will see that every generated video is saved with the prompt used. We also support multi-line prompt generation. So you can type multiple prompts like a dog strolls gracefully and let's say a lion. And when you enable this multi-line prompt, it will generate all 3 videos and save them in the outputs folder for you. Moreover, you can generate multiple videos as well. How? You see there is number of generations. Set this to 10 and it will generate 10 videos for each prompt with a random seed each time. So you can generate multiple videos and pick the very best one that you like. Okay, let's see the generated videos. It is like this. The prompt is not very detailed, therefore the video is not that great, but still it's a very decent quality and really fast. So how to use video to video? The video to video only works with this model, therefore select it, and for activating video to video you need to upload an input video here. So let's use one of the generated videos, for example this one. You see the video is here. The resolution of the video is this one, so I will set it and I need to type a prompt. I will try something really hard, a cat made of papers. And you need to change the denoise. Let's apply a strong denoise like 95%. Then let's generate and see. Alright, the video has been generated. However, since I did set number of images to generate 10, it is continuing to generate, but we can see the generation in the outputs folder. So when I open the outputs folder, this is the output. And yes, this is really amazing. I mean, I told it to convert this video into a walking cat made of papers and we can see that it did it. However, since we applied a huge amount of denoising, it's a little bit changed as expected. I mean the angle, the rotation, but it worked. So this is how you can use video to video. You need to experiment and find out what is working best for you. So I am restarting my application. Okay, what about other models like 14 billion parameters text to video model? The 14 billion parameters text video model is way more powerful than 1.3 billion parameter model. However, it is also extremely VRAM demanding. We are only able to keep low number of parameters in the VRAM, so I'm changing my preset to 32 gigabytes for the RTX 5090. However, how much VRAM I am using right now? I am using around 3 gigabytes, so it may not be sufficient. So let's make this 5.5 instead of 6.5, and we can select any resolution from here. So the native resolution is 1280 to 720 pixels. So let's generate a video on RTX 5090, and let's try to generate one on RTX 3090 Ti as well. These values are extremely delicately researched and set for you so that it will make your job easier. Both of the GPUs started generating the video. The speed of RTX 5090 is 82 seconds per IT, but I am recording a video. I will stop video recording, restart, and show you the real speed, and we will also see the speed of the 3090 Ti, and you can see that both of the GPUs are running right now on my system. If you are wondering my system, I already have two tutorials on my channel, this one and this one, where I have shown my system in details. I will put their link into the description as well, so you can find them easily. Okay, we got two steps in both of the GPUs, and 5090 is 70 seconds per IT and 3090 Ti is 183 seconds per IT. Okay, as a next step, I am going to test Wan 2.1 14 billion parameters 480 pixel model. This model is way faster than 720 pixel model because it is lower resolution. Therefore, this is more proper for consumer GPUs. If you want to use 720 pixel resolution model, you probably need to use it on cloud services like Rampod or mass compute. I recommend mass compute. So let's see the 480 pixel model speed. For this model to work, you need to have an input image. So I already have an input image for testing. It is here, this image, and how you should prompt it. For prompting, I am using Claude AI. And how do I use it? You can also use this for free. This is official and free to use on PoE. You can do a lot of prompts. Upload the image into here. Then use a prompt like describe this image like a movie scene. It will be used in a image to video model. So let's see what kind of description it will give us. Okay, it gave a lot of, so I will make it more dense. Convert it into a single prompt, single line prompt. Just describe the action of the scene. Okay, let's see what it is going to give. Sometimes you need to do multiple prompting. Yes, this is for example what we need. Then copy paste it, copy paste it. Okay, we got the model selected. Let's select 32 gigabytes and let's reduce a little bit. Okay, and generate. And also this is RTX 3090 Ti, so it will be image to video 24 gigabytes. Let's copy paste. Let's select the image as well here and generate. Then let's see the speed, and I will stop video and show you actual speed. All right, it has been some time and we got the speeds. The RTX 5090 is 20.5 seconds per IT and RTX 3090 Ti is 55.6 second IT. There is one very crucial thing that you have to be careful, which is selecting the correct aspect ratio for your uploaded image and selecting auto crop or manually cropping your input image. So pay attention to them, make sure that you have the prompt, you have the correct aspect ratio, the width and height of the image. If you crop yourself, it is better, otherwise our application will also auto crop. It is able to auto crop both input images and input videos. So I am going to repeat the test for the most heavy demanding model, 14 billion image to video model, 720 pixels, and I will show you the results. It is exactly same as using the 480 pixel model. So let's see the speeds. Alright, we got the step speeds of the RTX 5090 and 3090 Ti. 3090 Ti is 188 seconds and 5090 is 70 seconds. I have recorded them. So now I will begin you showing how to install and use on cloud services if you don't have a powerful GPU or if you want to scale your generation speed. Alright, to use this amazing model on a cloud service mass compute, my favorite, first of all go to the link in the description of the video. You will get to this link and download the attachments zip file from here, or in the attachments you will see the zip file from here. Then extract the zip file into anywhere. Extract, let's open the extraction. And you will see that there is mass compute instructions txt file. This is the file that you always need to read. We already have some example tutorials here. First of all, register to mass compute. Please use this link to register. I appreciate that. After registration, go to the billing and add some credits to your account. They also support crypto payment, which is amazing. After that, go to the deploy and you will get to this page. This shows the available GPUs and which GPUs you can use. If you use RTX A6000, currently you need to use at least 2x because the RAM memory of the single image is not enough. I messaged the team and hopefully they will increase it to 64 GB of RAM memory next week, but so far until it is increased you need to use 2. But my recommendation would be L40. This GPU has huge amount of RAM and also huge amount of storage. As a category, select creator, and as an image, select SE courses, and you will get my image. Then type our coupon. This will reduce price from $1.05 per hour to only 53 cents. This is an amazing deal. Then click deploy. Once deployed, you will get to this page and you need to wait the status to be initialized. If you haven't used mass compute before, you need to use Thinlinc client. Click this link. Download the application according to your operating system. Remember, mass compute is a cloud service, so everything will run on a remote machine, not on your computer. I am on Windows, so I will download this. Windows, click it, click yes, click next, accept, next, install. Then run. Then you will get to this page. So return back to your mass compute. Before starting, you need to click options and go to local devices, uncheck all and check drives, click details and add a folder here. This will be used to transfer files, but remember you can only transfer small files, not big ones. And make the permission read and write, and click OK and click OK, and wait for initialization to become green and running. This is super important. This may take between 10 to 15 or 20 minutes. It may sound a lot, but after initialization has been completed, mass compute is the fastest cloud service that you can find, and hopefully we will also improve the initialization speed. So the mass compute machine has been initialized. Let's copy login IP and return back to your Thinlinc client, paste it, copy this username, this is important, paste it, copy your password and paste it. And another thing is that copy your downloaded zip file and go to your mass compute share folder, wherever you have set. I have set it here and paste it there so that you can quickly copy that file into the mass compute. You will see, and then click connect and click continue. You see that there is an existing session. This terminates all of the running applications on mass compute, so therefore do not use it unless you need to. Okay, I click it start and it is starting the session. Mass compute has a desktop interface and this is the mass compute interface. We also have other applications you can see. So this is the disk space we have, this is the RAM usage and this is the CPU usage. Open home, and after opening home, go to the thin drives, go to the mass compute shared folder, wait for it to load. This is synchronizing with your computer shared folder, therefore it may take some time. Do not run anything here or do not transfer big files from here, it won't work. For big files transfer you need to use like OneDrive, Google Drive or Hugging Face or such. So our installer is here, you see Wan 2.1 version 7. Drag and drop it into the downloads folder, wait for copy and then right click and extract here. Then enter inside the folder, open mass compute instructions read txt file. First of all we will begin installation, so copy this with Ctrl C, open a new terminal, and when you get asked of this, click cancel, you don't need to, and then click paste. Remember that you have opened the command line interface in the same folder. You see downloads Wan 2.1 version 7. This is how you can start installation. Wait for Wan 2.1 folder appear, yes, like this, then return back to instructions, copy this part, Ctrl C, and click open terminal. How do I open terminal inside that folder? You see these three dots, open terminal, and paste it, and it will ask you which models to download. Let's download 2.1 14 billion parameters model as a test, so it is option 4, and hit enter. And the download speed of the mass compute is just mind-blowing. Let's see in real time. So it took only 18 seconds for 10 gigabytes of file. Yes, it is around 1000 megabytes per second. So the downloads of the models are really fast. The installation is also really fast. Just wait for installation to be completed. Okay, so the installation has been completed on mass compute. How do I know? You will see that virtual environment made and installed properly. The model has already been downloaded. So return back to instructions txt file and copy this prompt. This is for starting the interface. Copy it. It will start the application. Return back to the folder and click three dot and open another terminal and paste it. Now this is going to start the Wan 2.1 application, and we will be able to use it in our computer or in our tablet, in our phone, anywhere. You see there is this URL. I will copy it and I will use it in my own computer rather than inside the mass compute. So copy paste it. And you see the interface is loading in my computer, and yes, this is running on a cloud machine on mass compute, but I can use it in my computer. So let's use our downloaded model. Let's select the GPU. This is the GPU preset. The usage is same as in Windows, so I will copy paste this. Verify your resolution, aspect ratio and everything, and click generate. Then it will load the model and start generation. To see the progress, return back to your Thinlinc client and watch the interface, the command line interface here. Let's see what is happening. We can also start nvitop, so open a new terminal like this and type nvitop. Okay, it is loading the model right now. We can see the VRAM usage is increasing. Yes, you see my presets are really optimized. It is using almost entire VRAM. It will take some time on this GPU, but we will see the speed and generation result. So our generation on mass compute has been completed. This is the video. I mean, it worked really decent if you consider the prompt. This is a very weird prompt and it worked really well. To download the model, you can use this icon. It will download into your computer. If you generated many videos and if you want to download all of them at once, go to your installation folder, Wan 2.1, Wan 2.1, enter inside output and copy the videos that you want, or you can just copy the outputs entirely, move it into the thin drives, paste into your synchronization folder. Let me demonstrate you. So I will paste it here with Ctrl V, and it is copied here. Wait for copy to be completed. It may take some time. Then go back to your synchronization folder and it will appear here. So then copy them into your computer and it will be synchronized as you are seeing right now. On mass compute, you have to terminate your machine. There is no stop or resume feature. So go back to your running instances here and click this terminate icon. However, be careful because when you do that, everything will be deleted permanently. There is no restore back, there is no recovery, nothing. So make sure that you did backup everything and then click this icon and it will delete it. And you see we only paid 50 cents for per hour. So this is a great pricing, and let's just delete. If you want a faster generation on mass compute, the recommended GPUs will be H100 or A100s, or you can use L40S, but it is not as fast as these other ones. However, you can also rent multiple A6000 or L40S and start application on each one of them and generate multiple videos on different started applications at the same time in parallel. That is also perfectly possible. How to do that? Open your mass compute instructions files and you are going to add a command here like export CUDA visible devices equal to 1. So once you start your application like this, it will run on the GPU ID 1. If you make it 0, it will run on the GPU ID 0. If you make it 2, it will run on the GPU ID 2. So let's say you have rented 4 GPUs and you can start 4 applications like this and each one will run on a different GPU. So you will be able to generate multiple videos at once. Keep watching the video. Alright, now I will show you how to use this amazing model on a cloud service Rampod. This is one another favorite cloud service. Click the link in the description of the video to open this page. Remember to watch the Windows tutorial part to learn how to use the application. So download the installer from here or from the attachments you will see here. After downloading the attachments, extract it into any folder and enter inside the folder and you will see that there is Rampod instructions read txt file. Open it. I recommend you to register with my link if you haven't yet. I appreciate that. After registration, go to the login with sign up button, then go to the billing and add some balance to your account. After you have added account some balance, after that go to the pods and click deploy. Now which GPU you need to use? On Rampod you can use pretty much every GPU, but according to your GPU your speed will be slow or fast. So I recommend to use at least L40S because it has the sufficient RAM and also VRAM, a little bit sufficient VRAM, not fully, but still it will be good. If you want faster speed you can use H100 PCI or you can use A100 PCI Express as well. Let's go with H100 PCI Express. Click change template and type PyTorch like this and select the PyTorch 2.2.0. This is the template that you need. Click edit template. I really recommend to add a lot of space if you want to test especially all of the apps. Let's add like 300 gigabytes. This is super important. Set and then click deploy on demand. Then click my pods. You can also click your pods here. Verify that your machine has sufficient RAM. How much RAM is sufficient? At least 96 gigabytes of RAM I recommend to get. It will make it faster. And wait for pod to be initialized. How you will know it is initialized? The connect button will appear here. You can also refresh this page if you want to see and connect appeared. Then click connect and click connect to Jupyter Lab. You see this interface. Click it. This will open the Jupyter Lab interface of the Rampod. Remember, this is running on a cloud machine, not on your computer. Wait for this interface to be loaded. If this interface doesn't load, you need to get a new pod and you may encounter broken pods on Rampod a lot. Moreover, if you want even more cheaper prices, you can go with Community Cloud. However, this can be extremely slow or more probably broken pod. Then click this icon for upload. Upload the downloaded zip file into the workspace. Once the upload has been completed, right click and click extract archive. It will extract all of the content. Click this to refresh. Then double click and open Rampod instructions txt file. This is the installation command. Copy this, open a new terminal like this and paste it and hit enter. This will start installation. Wait a little bit until you see the folder of Wan 2.1 here. Let's see. Let's just wait a little bit more. If you stop your pod and resume later, you need to run this installation again. It will be way faster second time, but remember that. Okay, now we see that Wan 2.1 folder arrived. We can begin downloading models. So for downloading models, copy this. You see download, open a new terminal and paste it. You can also right click and paste and it will ask you allow and it will paste and hit enter. Now which models you want to download, it will ask you. This is exactly as in the Windows tutorial part. So for demonstration, let's download the option 4, 14 billion parameters text to video model. You will notice that I am optimizing the downloader extremely well and therefore the download speed will be really fast. Let me show you the download speed. Yes, It is 400 megabytes per second, 1 gigabyte per second, 1.5 gigabyte per second, because our pod is a good pod, expensive pod, and I am optimizing the download speed. If I didn't optimize it, it would be only 40 megabytes per second. You see the difference? It is huge. And then we need to wait for installation to be completed. Installation may take huge time on Rampod. It totally depends on your pod, and on Rampod, hard drives are usually very slow compared to the mass compute. Okay, so the installation on Rampod has been completed. How do you know? You see virtual environment made and installed properly. After installation has been completed and you have downloaded the models, you need to copy this command with Ctrl C, open a new terminal and paste it, and it will start the Gradio interface that we can use from our phone, tablet, TV, wherever you want. It will be Gradio Live Share. If you don't want to use Gradio Live Share, you can add 7860 port as a proxy and use it, but I recommend Gradio Live Share. Click this link you see. It will open the Gradio Live Share. Then the rest is totally exactly same as in the Windows tutorial part, but as a beginning, let's try and see the speed. So I selected this, and since this is a powerful GPU, I'm going to use 80 gigabyte, and I am going to disable tiled VAE, so it will be fast. And as a prompt, let's try this prompt, generate, yes. And let's see the speed on H100 GPU. Okay, you can monitor the status on here. Let's also open a nvitop to see pip install nvitop, and we can see, yes, it is already starting to load. Okay, wow, this machine is really fast. Let's see the step speed. This is running on cloud machine, not on my computer. Always remember that. It is using 43.10 gigabytes of VRAM memory. Okay, we got the first step. It is 57 seconds per IT. It is not really that fast, unfortunately, as fast as we expected. So therefore you can also get L40S GPU and pay lesser. It is up to you, but this is the speed on H100 GPU for the very best model. Therefore you can get an L40S GPU and get similar speed, pay lesser, and really generate a lot of images. For example, I started 8 GPUs and I am going to generate on 8 GPUs to prepare some of the examples that you have seen in the beginning of the tutorial video. So that is how I am scaling my generations using multiple GPUs. I'm going to download all of the models here. And how I am going to do that? I am going to assign a GPU to every instance. It will be like export CUDA visible devices equal to 1, 2, 3, 4. So each one will run on the different GPU. Therefore, I will be able to generate multiple videos in parallel. This works on mass compute as well. This works everywhere on Windows as well. In Windows, it is set, not export. But this is the logic. So this is the logic of using Rampod. Exactly same as in the Windows part. You just make the installation as this way and you generate and you download things you want. So our Rampod generation has been completed. We can see the time it took and we got the result. The result is just mind-blowingly amazing. It is extremely high quality, as you are seeing. Really good from this description. I really like it. So how you can download it? Click here and it will download the video into your computer, or go to the workspace Wan 2.1 folder and outputs. Right click and download as an archive, and it will download all of the generated videos inside a zip file like this, so you can open and see them. If you don't want to spend any money, you can stop your pod from here. Click stop and stop. It will use minimum amount of money. Then you can resume with start and just run the installer again. It will be very quick and start again. If you don't want to spend any money, just terminate, but this will delete everything forever. So be careful with that, just terminate. If you want to use storage system of the Rampod, I have a full tutorial for that. Into the YouTube, type SE courses Rampod network and you will get to this tutorial. This tutorial shows you how to use permanent network storage system if you need permanent network storage system on Rampod. Thank you so much for watching. Hopefully we will meet at more amazing tutorial videos. Please go to our Stable Diffusion Generative AI GitHub repository and star it, fork it, watch it. If you sponsor, I appreciate it. Please also go to our Reddit. We have a Reddit page. I am constantly sharing extremely useful information here. We are growing, so follow our Reddit. Also, I have a LinkedIn profile. You can go to my LinkedIn profile and follow me here. I am constantly sharing updates, a lot of information. You see, I already have 6,000 followers. I appreciate everything. Also subscribe to our channel, leave a comment, and hopefully see you later in further tutorial videos.